28, let me know. So welcome back. Let's get back again.
28 minutes, right?
Yes. So, what topics could I possibly help you for with your final exam meeting tomorrow?
Everything for the
Thermodynamic movement.
Yep.
Yeah, but you gotta let me know the words.
Oh,
Hello, come on in. Hey, welcome. Hey, Eric. Bye, Eric.
Wait, what unit was that?
Coefficient was unit 5.
No,
Sorry, unit 5 and 6.
Thermodynamics.
9.
9?
Yep, thermal was 9.
Oh, there's a lot of books I have. I thought it was
So, one
Yeah,
of the things,
that-
this is for the YouTube video, one of the things we just talked about really quickly was coefficients. Coefficients are, that's a coefficient, and this is a subscript.
What's happening?
Subscripts tell you the number of atoms. For example, there's 2 atoms of hydrogen here, only 1 oxygen. Ones are invisible. And this tells you that there's 1 water. So there's 1 molecule of water. Also, sometimes you need to be careful because you might have something like aluminum sulfate, where there's 3 sulfates, 12 oxygens, and now there's a bunch of oxygens. So, there's that. You just gotta be careful with it. It helps you count atoms. It helps you count atoms and molecules. So there's, 6 atoms of aluminum, but only 3 aluminum sulfates. So this works for the whole thing. For this, only works for that. And this, actually, you know what? I'm gonna make that blue. And then this works for that. Yeah. It helps with stoichiometry. It helps with stuff like that. The mole problems, things of that nature, and sort. Yep. What else?
Gibbs free energy.
Gibbs free energy. Gibbs free energy is the amount of energy necessary to do work. The amount of energy needed to do work. Unit 6.
Manny Ayala, please report to the front desk. Manny Ayala, please report to the front desk.
So that's the spontaneous versus non-spontaneous thing. Yes.
Specific heat capacity.
Specific heat capacity is another Unit 9 vocab. This is how much energy is needed to raise 1 gram of something. It could be anything, could be anything. Everything has different values. 1 degree Celsius. Here, let me erase that. That's a pretty bad one. That's a pretty bad one. So, it's a pretty technical definition. What you need to know is that in Q equals MC delta T, it's C. And what that tells you is, that tells you essentially how quickly something heats up. So for instance, like and I didn't do this with you guys, but I did it with some others. Sorry, I'm just trying to look for something really quick.
How fast it what?
How quickly how quickly something takes to heat up. So for example, if you put a wooden spoon into a pot of boiling water, if you leave that spoon in the pot of boiling water for a long time, you'll notice that it's still a wooden spoon. Is it going to get very hot? Or a plastic spoon? If you put a plastic spoon in boiling water, is it going to be very hot? So, here's something that we'll do. Here's something that we can do. Let me finish this email really quickly. So, we clearly have something where we can maybe ask a question. So, I'm going to put okay, I'm going to put this on 10 out of 10 heat. I'm going to get a beaker. I'm going to get a metal tongue. And I'm going to get, I know exactly what I'm going to get. I know exactly what I'm going to get. I'm going to get a spoon. Nice. Okay. So I have two very, very distinctly different things. I have plastic knife, and I'll go over here. I have a plastic knife, and I have a metal tongue. I'm going to put these both in water, which is going to boil hopefully quickly, and then we'll see what happens in a bit. So, just so the YouTube people can understand and see what's going on. So, that's on. It's hot. I have a plastic knife, and I have a metal tongue, okay? And this is going to talk about specific heat. So, we'll kind of see what that ends up. So we're going to kind of go back to this and go back there a little bit. So now you can adjust again. Again, once that gets boiling, we'll talk about that for a few seconds. What else can we talk about? Multiple choice is a lot of just a bunch of questions. I can't really say too much. It's going to have a lot of multiple choice on it. I just said the multiple choice is going to have a lot of multiple choice. It's going to be a lot of vocab. It's going to be a lot of vocab, but it's not all vocab. There's some things where I'm going to ask you, hey, do this, and you'll be able to do it.
But most of the parts that
But it's no math necessary.
most of
Do something that involves math.
Do something that maybe involves vocabulary. Because I don't have to just give you vocab questions like, what does this word mean? What does this word mean? It might be, like I might give you a potential energy diagram and ask you, is this endo or exo? And then you have to use your knowledge of those words to say, okay, it gained energy, it's endo. It lost energy, it's exo. Stuff like that.
Can we go over enthalpy and entropy?
Enthalpy and entropy. Delta H. So this is about heat lost or gained. We already know the difference between those two things. We got endo and exo. Does endo gain or lose? Gain. Is it positive or negative?
Positive.
Positive. this one loses and is negative. Entropy is about how organized a system is. And that's really what it's about. So on the, there was a background I had earlier in the school year that pretty much said like, hey, things are crazy, finals is nuts, you have to do this, that, and the other thing. The universe favors that. The universe wants everything to be not so crazy. That's what it likes to do.
Could you give us like an example problem like that? Like not like what is this, but like where we would have to use those definitions to answer it with
So
these two.
you've seen a lot more than with enthalpy, because
Yeah.
those could be potential energy diagrams. Those could be, like, not talking about this in a vocabulary sense, but I could ask you again, if you're doing any of the math problems with ethno and exo, like say you're doing Hess's law. At the end of the day, after you add up your laws, your three numbers, your four numbers, I could say, hey, is this endo or exo? Well, if it's positive, it's endo. If it's gained. If it's negative, it's exo. If it's lost. Problems with this one, it's going to be more like this. So for example, I could ask you, and I'm sorry for that arrow's not cooperating with me. So if I have water that's going from a liquid to a gas phase, or a gas to a liquid phase, so it's going to condense or boil or evaporate. It's going to do one of those three things. Is this going to want to go forward or backwards? So think about that for a second. Don't answer anything. Think about that for a second. Does this want to be forward or reactive? Sorry, forward or backwards? Point to which way you think it's going to go. Do this or this. Or this way or that way. Which way is better? If you don't know, Fisk. Okay, it's tied. I think it's 2, 2, and 2. The answer, actually, what were you? You might break the tie. Ooh, okay, so that broke the tie. The answer is this way. Gas is more chaotic than a liquid, right? Gas is more disordered. Gas is all over the place. Gases, and because gases are more disordered, it's going to favor that. Gases are all over the place. Liquids, maybe a little more all over the place, but still not really all over the place. Gas particles. Liquid particles will be like maybe like that. Gas ones are more like that. Further away.
Mr. In the homework that you gave us recently, where we had to say if either the reactants or the products
Yes,
were
favored. Yes, equilibrium.
favored,
Yes.
what was the like? What did we have to do?
So
I forgot.
now when you had just when you were calculating your values for K, if the number was bigger than 1, it's favoring the products, and if it's less, it's favoring the reactants. And that's again an example of vocabulary that would possibly be like application. So like you need to know what equilibrium constant means. It means like what's going to be favored. Is this direction go forward or backwards? I could say, hey, your Kc value is 7. Which way is it going to go? Products or reactants?
Products.
It's going to go products because it's bigger than 1. But you need to know that vocabulary, right? Or you won't know.
But for tomorrow, we wouldn't have to like actually find out like
You do not
if
have
it's
to do
7.
it. Nope, no math at all. I feel like you guys don't believe me. I get so everyone's asking me all day, so no math. Like you guys really think I'm lying to you about that, don't you? Maybe I should add one just to be a troll.
So it's just
No.
over here. Is that
It's I don't think you were here when I said it, but I'll say it again. So I'm not, and I apologize, YouTube, but we're not going to say the actual number. I looked at the first 20 questions, okay? And don't say anything out loud. I don't want the YouTube video. You guys are here, so you guys deserve something. And we'll see if anyone calls me out on this too after we watch the video. There were this many out of 20. Can the video see me?
No.
Okay, cool. There's this many out of 20 that were vocab based, like directly vocab based, in the top 20. So it's not the whole thing, obviously, but can we agree it's a decent number? Did you see the number I was trying to make? I wasn't doing this. I was doing this. Young money.
Do you want me to move it so I can see you now?
I don't want them to see it.
Oh, okay.
That was for you guys.
No, I mean like so I can see you now.
Oh, that's fine. I could be the overarching voice. I am the one narrating the story from behind the screen. Ignore the man behind the screen. Yes?
Can you give examples of bond enthalpy problems and enthalpy of formation problems?
Yes. Okay, let me copy and paste the problem. Enthalpy of formation. You ask a great question. All right, is it okay with you if I just do the, if I go to the, where'd it go? This might be it. Can I just use the practice problems I gave you from the math practice? Is that okay?
Yeah.
Is that okay? Because then I would be doing one for you. Is that okay? That is going to be these two. Do I have enough on here? Plus. Holla at your boy, holla at your boy. Now this, it's gonna do it. I knew it was gonna do it. Okay. So, you'll have to forgive me, this is gonna take a few seconds.
Which problem is that? Oh.
Yep.
Wow.
Wow! We got some like Naruto up in here. It's true. Naruto is like, stop denying it. Okay, so I got this type of problem. Now I'm gonna be honest with you, this one is harder than this one because this one I give you the numbers and you just need to like apply it. Is it okay if I do one of these instead?
Sure.
Yeah.
The harder one, can I do the harder one? To make the, and then we'll do it, if we need to do this, we'll do this. Okay? So, here's the thing. So this is the enthalpy of formation, which this is the bond one, but the enthalpy of formation can also be like this. The big thing is that you must balance the chemical reaction. Here, I'm gonna be honest with you, it's all ones. 6, 6, 3, 3, 1, okay. If these were 2s or 3s, it would impact them. Okay, so this isn't balanced. But for the sake of this problem, I am going to, on purpose, say that there's 2 Cl2s. I know it's not balanced, I'm aware. We're going to assume this so you know how to do it, okay? We're gonna let that boil too for a little bit. So what you need to do is will be given the Lewis structure. C6H6 looks like this. Sorry. It's going to look like this. And again, I know I'm not drawing it very nice right now. If I had a pencil and pen, it'd be a lot nicer. So you'll be given the Lewis structures. So what you need to do with these is you're going to need to look at the bonds, and you are going to need to find the individual total enthalpies from each of these things. So, for example, how do we do this? In this one, I have 1, 2, 3, 4, 5, 6 CC bonds. And I have 6 by CH bonds. 1, 2, 3, 4, 5, 6. Here, I have 1 by CL. Here, I have 1 by HCl. And here, I have 6 by CC. 1, 2, 3, 4, 5, 6. I have 5 by CH. 1, 2, 3, 4, 5. And I have 1 by CCl. Question, Nancy? Good. Yes.
Are the load structures going to be provided?
Yes.
Okay.
Yes, I will. And honestly, this is a big organic molecule. Like this, even if I made you do it, I would not ask you to do something this big. Then what you would need to do is you would find all these numbers out. Now again, with this one, because there's a 2, I know for a fact that ClCl is,
239.
where is ClCl? 239. So this will be 239. But there's 2 of them, because there's 2 Cl2s. So for that reason, you would have to double it. This one, and if you don't mind, just for the sake of this, because you can pause the YouTube video, I'm going to solve these myself. Where is the... This is what I get for giving you guys like 2 different options. So those are the 4 numbers that you will need. CCCH, CCL. Yep. We're gonna see how this one. Yep. So those are the numbers. I'll step away for a second. Those are the numbers that you're going to use. And then you just quickly do that math. So what will that look like? So 6 cc's, 6 times 347, plus 6 times 413. This guy is 4,560.
Mario Garcia, can you please report to door 1? Mario Garcia, can you please report to door 1?
And the HCl is 427. So those are the numbers that we got from these guys. And then all you need to remember with these, what's the equation? The total is what minus what? What do we put first? Here, I'll give you a hint. What goes here and here? It's something minus something. What do we always do? Is it products minus reactants or reactants minus products? Products minus reactants, right? So with this problem, it would be 4486 plus 427 minus the 4560 plus 478. So again, I literally just did products minus reactants. And the answer I get is negative 126 kilojoules per mole. Now again, I am omitting because I know if anyone watches this video, yes, it's wrong because of this. I know I made up a 2, but again, it's just to show, again, you have to make sure that you're keeping that coefficient in mind. This table would be given to you, the Lewis structures will be given to you, this is not given. And while people are still maybe looking at that, I'm going back to this guy because it's obviously boiling. So this has been boiling for a good 5 minutes. Can we agree, kind of? Ish. Okay? So different things heat up in different ways. For instance,
Is that Miss Keisha?
this was in boiling water for 5 minutes. I'm holding it with my bare hand. Does this heat up that much?
No.
No, right? This is going to take a lot of energy to heat. To be honest with you, water even takes the cake. Water took a lot of energy. It didn't start boiling for like 10 minutes. I have it on 10 out of 10 heat. It took 10 minutes still. This is honestly already like not that hot. Like it's like room temperature already. Okay, this is a little hot still. But again, as I'm absorbing the energy, it's going to lose it. So I'm cooling it down by touching it. It's XOM bendo. And I have a cool plastic knife that's like this. So that didn't heat up very much. That didn't heat up very much. And I'm a wuss with heat. You guys know that. I've said that enough times. I'm a wuss with heat. I can easily hold this in my hand. No funny business.
Show the subscribe.
How do you think I'm gonna do holding this guy?
No.
I'm about to hold the tong.
You're gonna have
Do you think I even want to do this? No, it's a metal. Metals heat up. Now again, if this is aluminum, like for a baked potato, like aluminum cools and heats up pretty quickly, but also cools down really quickly. So there's a chance I'm okay. But if this thing is an aluminum and it's iron, iron heats up and stays hot for a long time. So if this is iron, I'd be a little silly. I can hold that for about 2 seconds. That wasn't even 2 seconds. But I know it can be probably about 2. This, if I held it as long as this, which is already cooled off by the way, I'd burn my hand. That's the difference in heating things up. So again, check it out at home. Take a boiling pot of water, put a wooden spoon in, and put a plastic spoon in, and put a metal spoon in. See the difference after about 20 minutes of boiling. I'm gonna leave this go. Also, does anyone want a cool knife that's bent? Anyone want a bent knife?
Yes.
Souvenir, you want it? Here, take it. I did just duck it back here. No, you're good, you're good.
So this is
Here, I gotta let it be exothermic into me for a second. Sorry. I am becoming endo. I don't want this. I don't want you to do this.
You're right. Is that a weapon on school?
It's not bad.
My life. Like it?
Try to cut something with it. At home, like when you go home and you have your food, use that.
Yes.
Just whip it out and be like, have your family go, what the heck is this? You'll do it too?
What?
You'll do it?
What? Oh no, it's because.
We actually do it though?
While I'm eating? Sure.
Yeah. Okay, you real MVP.
I'll just pop it out when I get home.
Okay, here we go. And really, this one takes a longer time than the other one, because the other one I'm going to give you all of these
Taylor.
values.
28.
Oh, 28? Okay, so that's a good point to stop.
What's about
Next!
29.